So I'm used to teaching this class 8 o'clock in the morning, so it feels like I'm back in class. And it's very hard to keep students up 8 o'clock in the morning in fall, especially when it goes to November, December. So, and we don't in classrooms, so it's just more challenging. So I'm going to talk about my experiences in using GENI in a cloud computing course last fall in University of Missouri, and this is a slide that I adapted from the textbook that I picked, which is written by Huang Fox Dongara, and I kind of put some topics that I covered, removed some topics, but it spans a range of topics from technology to policy to issues of experimental test beds and cloud applications. So there are lots of interesting concepts to cover, and the way the course was structured was we wanted to have the students really understand the principles and architectures that we need to build cloud computing systems, the theories and the IT technologies, and they need to understand distributed system models at the fundamental level and virtualization concepts. And I did spend quite a bit of time on network virtualization. And in fact, the textbook had no material on network virtualization, so GENI was very helpful in supplementing that piece of material. And one of the other emphasis was all of the students had to be competent in programming distributed systems and build applications and actually work with some available cloud platforms. So we used both GENI as well as Amazon Web Services for this course. And there were other topics which you have to cover when you do a cloud computing course on cybersecurity, service-oriented architectures, web services, and things like that. And obviously the applications are key to really understand how you build and sustain and enhance cloud infrastructure. So that was sort of covered at a more higher level, but really the concepts and models and understanding how to program in a distributed system was key on available cloud platforms. And so it was very hard to come up with a prerequisite for the course, but it looks like we need lots of prerequisites, but given that we had undergraduate students and mostly graduate students, we kind of just went with object-oriented programming as the prerequisite. And fortunately, the textbook that I used initially, I was not sure if it would be useful, and this was the first time I was teaching, turned out to be quite useful. So I used close to 50-60% of it and supplemented that with slides from other places and my own research. And we had some optional textbooks because we used a lot of Amazon Web Services based labs also. And the key part that make this course work was a good teaching assistant who attended the summer camps, many of the GENI conferences. She's doing research in her thesis on the GENI infrastructure, so that really helped in taking the class in a sort of a very detailed handheld way, but also at a more advanced level way where peers could talk to each other about what was going on in the class. And the GPO's help was very, very critical, and we really thank the GPO team for helping us. And we did have a discussion board, and this is a snapshot that shows initial first lab, there are about 15 kinds of conversations. As we go on to other labs, it becomes lesser. So most of the labs went pretty smoothly. And we also had a tour of the data center where the GENI rack was just getting installed in fall. So that was really, really exciting for the students. So we did have a tour piece of the class to look at the GENI rack. And we had, a good set of theory, but supplemented with laboratory exercises. 3 exercises that were based on Amazon, 3 based on GENI, and both were very complementary. So each reinforced the other. They had similar concepts of, the first basically the setup part, second piece where they are understanding the infrastructure, third where they are actually looking at scaling and performance kind of issues. And I'll talk a little bit more about the GENI labs next. So the GENI Lab 1 really was new. The GENI portal got set up last fall where I got an account. I was able to have all the students, the 30 students and about 5 visitors basically register and go through these steps of understanding GENI terminology, and as well as having to do a basic experiment, right, the Hello GENI experiment. And the purpose was they had to really understand what goes on in an experiment workflow, and they were asked to basically use both the command line tools as well as the GUI tools, and they were given very, very detailed instructions step by step to do things, because this is the first time they're actually using any of these kind of tools, and a distributed system programming is not something they do quite often. So a lot of detailed steps had to be given, and at the end of the exercise we asked them basically questions that made sure they understood what they clicked. So here are steps, go click, 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 try to do this, but then did you really understand what you clicked? So have some questions on that. And one of the best things for the first lab exercise was we were talking about federated identity access management, and I was kind of telling them, so you could have your username, password of your institution, not leave your institution, but access federated resources. The best way to demonstrate that was through the GENI portal, which is one of the service providers in common. So this was one of, for me, a really great way where they could just use their campus pop prints and then get onto the GENI portal, use GENI resources, and all of the detailed theory and explanation I gave on federated identity access management, they were able to kind of see it in action as part of their first lab exercise. So that was really a very fun part of this course. In the second part, it was about instrumentation, measurement, understanding the infrastructure, deploying a distributed application. And so we have a project in GENI we've been working on for the last 3-4 years. It's called On-Time Measure, and it was built for raw PCs in sort of the non-GENI rack era. And now with GENI racks and having to use VMs and having 30 students in the class, each needing 3 VMs or more, like 100 nodes set up, we did go back and refactor some of the code and got that to run. And here they were really trying to understand all of the services within GENI in order to interact with sort of the distributed system components, right? In terms of how the data flows happen, how the control flows happen, how you use web services to interact with different pieces of your experiment. So this gave them that exercise. And the last exercise, which is GENI related, was really putting them to do some SDN kind of understanding, and basically write open flow controller applications. So we had 2 applications that we introduced. One was really to do QoS control for network edge rate limiting based on some policies, and the second one was a load balancer. And we used the floodlight controller, and we had basically a ping utility to do different kinds of tests. And one of the piece of the exercise was they had to actually run this within Mininet and understand how to debug their controller, look at the protocol packets and modify them. And so the experiment for the QoS control, they were basically varying the policies on both sides on different paths and kind of looking at the effect of it by running iperfs. And then they were also doing a load balancing experiment with a few load balancer nodes, a few end hosts, and trying to understand how the topology can be scaled as load increases and how you handle load at different load levels. So they understood this with the SDN application. And the last part of the project really was about reinforcing all of these concepts that they learned in the course as well as in the labs to actually apply them to a real application within a available cloud platform. So we basically had group projects. Graduate students had to do the project. Undergraduate students participation was optional, and the idea was that they have to solve a real problem. So don't give me a fake problem, or just don't write me a website. Do a real distributed systems problem with web services. Have a core logic that's solving some problem. Have a testbed team that's really focused on setting up the infrastructure, the GENI pieces and the tools. And most importantly, every application needs a really good user interface. So reinforcing the idea that you have to spend time and make sure all you build needs to be presented very well is also something we emphasized. And they basically did an engineering project, so they were asked to look at trade-offs and understand the infrastructure and change it and show how that infrastructure sort of responds to different controls. And we had a bunch of circle times. This is from my son's daycare, where you can get around in the class during the class, because it's very hard to have students meet outside the class. So we had lots of circle times, and we had presentations, and we had a good chunk of the code, 20% of the grade, based on team performance and peer reviews. And the projects they did were projects that are ongoing within our lab, and many of the students in each of these projects have basically their thesis work in this area. So they are basically domain experts for each of these labs, and they worked with the group of teams, and they were given requirements. If you can look at this, there is a platform project, there's a software as a service project, there's a performance project, and there's sort of a app marketplace kind of a project. So it spans sort of the key principles of what we were trying to accomplish as part of the course offering. And we were given the option, the students were given the option either to use GENI or Amazon Web Services, and I would say 3 of the 4 projects took a shot at both, and most of the final demonstrations, all of the user interface deployment were in Amazon Web Services. As you'd imagine, it's pretty easy, but literally a lot of the advanced stuff that they wanted to do in the project only is possible in GENI. In fact, students are continuing to do that beyond the course through other projects. So there was an interesting dynamic when we had people choose infrastructures for the projects. And the last slide I have here is sort of with the big findings or things that I didn't know when we started the course. So this was the first time I offered the course. This was my first year at University of Missouri. I had really no good background of what courses they had taken or what were their knowledge levels. And given that this is such a new topic which spans a big set of prerequisite knowledge that you need to understand, I was not sure how to do the course, and especially the lab piece, how the students would respond if I give them a lot of very basic to very advanced set of things to do. And it turned out that I went the safe route by giving them every step-by-step instruction, and even then students had some problems. And again, at the end of the exercise, I gave them questions basically to reinforce or test them or change the the command line things or try different things. So that definitely reinforced or made sure people understood what the learning objectives were, but it needed a lot of hand holding. And the other really good part I found using Amazon Web Services and GENI in the same sort of course structure format, and basically gave Amazon first, GENI second, so on and so forth, 3 labs each. And so they got this very easy, very sort of well documented Amazon Web Service experience, and then they were doing the GENI, and it was not, as I showed from the discussion board, they were not really struggling in GENI. They were having pretty much the same experience as the Amazon labs, and they were very similar approaches in the tool usage, the best practices. So it was really very interesting to see the dynamics of a public cloud and sort of the GENI cloud. And then, like I said from the beginning, the coordination with the project office was very, very critical in ensuring we had the right timing of labs, the resources were available, and if we had some issues, as I said, in the development of the labs, we were sending it to them, having conference calls regularly, checking with them in terms of what we were doing and what was available. As the GENI racks were coming up online, there was lots of variability in sort of how we got the resources. But I think it worked out really well, and we really thank the GPO for helping us. And the last piece was really coming to the end of the course. As we started doing the SDN part and the projects, I felt in a semester span, it's very, very hard to cover all of that. And really, we could not get our act together in developing the labs to actually run the OpenFlow controller in the GENI infrastructure. So they just ended up doing it in Mininet. So hopefully, going next time, we're going to offer it next spring, and we'll actually try to get the GENI infrastructure set up for running these kind of OpenFlow controller applications. We have lots of nodes. We have many interesting things we want to try. So we didn't have enough time to figure it out, and also we didn't know how the students would cope in sort of getting into the GENI infrastructure, understanding how to do this. So that's sort of an open challenge. And the last part I felt as we had the projects completing, like I said, they were different kinds of things people were trying, and the amount of work we want to get done in the projects was sort of limited, I would say. They got through in showing a good demonstration, but definitely for doing more in-depth GENI experiments, my plan is to have a subsequent course right after I do the Cloud Computing 1, to have a Cloud Computing 2, where the students can take on those projects and sort of go one more semester in learning advanced concepts and sort of expanding the project. So that's a takeaway for me for the next offering. So that's my talk. Can you repeat the question? Yeah, it's easy. We have the PDFs. We've shared it with the GPO, and we can put it on a website. But like I said, there is some things that are specific to their operands or the way we had done the labs. But I think if people can, because all of these steps have some sort of a approval process, where even for the GENI portal or for the on-time measure, anything you need to approve students joining these things, and so there is a little administration. So maybe I need to augment the existing materials with some of those administrating sort of logistics. But I think the PDFs, if anybody needs it, they're available. I can share it with them.
Pretty generic, like it's not.
They are very generic.
Tied to your course
No,
content.
it's tied to the GENI infrastructure, which is also changing. So I'm not sure how that will span. But most part, I think they are very repurposable.
How do you deal with availability of resources when you have a whole class? I mean, how many, is it okay for each student to have a slice, and then how many notes can you have in each slice before start?
So there we had to work with the GPO, and each student was asked to go to a particular aggregate manager to get their resources. So we did sort of a manual load distribution. So in future it would be nice, as we have more GENI racks and more students coming, so this hand holding of resource allocation can be automated. That will be cool. But right now it was sort of manual, and students were asked to pick an aggregate.
And then how many students ended up at each site, and with how many?
6 or 7 per site, because we had like 30. We had, I think, 5 racks, and some racks they were just coming up, and we needed public IP addresses to get to some things. So some didn't have that capability. So we had to work through some small kinks, which I think probably now is not an issue in GENI. But when we were doing it, we had to sort of play around and have some standbys and things like that. 30 students, registered about 5 who did the labs and sort of walked in and walked out. I would say it's more of the flexibility. They understand actually what's going on behind the rack. Like I said, they saw the rack, they have the rack architectures advertised. They have a lot more understanding of how the cloud is built. So I would say the behind the scenes, what's happening, if I needed to do more of that, in Amazon, it's really a black box. So like this example, I think the resource allocation in Amazon, they really don't see it. They just ask, it's available, right? You can obviously pick the region in which you want to get your resource, but if I wanted them to understand a resource allocation problem, implement it and sort of force that, they have a better understanding what's going on, and they can set up, more elaborate. Yeah, location guarantee, also architecture of how things are set up, and we can talk to somebody and actually change things the way they are by default and things like that.
You actually use the hardware switches in the GENI platform.
Right.
He actually use the hardware switches in the GENI platform to do some dynamic
Load balancing could not have done in the infrastructure. Yeah. Thank you.
Can you hear me well? Not sure. Huh? Yes, I think. Okay, so I will be talking about teaching cellular networking with WiMAX Labs. This work was done at Columbia University. My name is Jelena Marašević, and other contributors were Jan Janak, Professor Henning Schultzrin, and my advisor, Professor Gil Zusman. So feel free to interrupt me at any point and ask me questions. Okay, so when we started teaching WiMAX, when we started teaching cellular networking, our main goal was to introduce students to the cellular networking concepts. The main reason is this is something that is not normally taught in networking courses or wireless networking courses, and there were no hands-on labs. So some three teaching objectives were to explain to students how does centralized allocation of resources work, which is typical for cellular networking systems, to show this by comparing cellular networking to wireless LAN, because in wireless LAN we have a contention-based system where users compete for the resources, whereas in the centralized control everything is under the base station's control. We wanted to teach students, to make them understand what is the channel impact on the performance, in particular how does channel affect the throughput, and we also wanted to teach them about quality of service mechanisms. So the lab was organized for the first time back in spring 2012. We had a WiMAX base station, 2 mobile stations. So we actually used 2 laptops as mobile stations. They were connecting to the base station over the WiMAX interface and sending all the experiment data through the access service network outdoor unit, and indoor unit are the base station, and access service network gateway is another element connected to the base station. So this all comes with the WiMAX setup. We connected the Linux. We were with this lab, it was good, however, it was not perfect, and we identified the places where we could improve it. First, there were, to show